Hello again, it's Thursday. We're on number 63 of 70. Here's some reminders at the top. What do we do here with those exponents? We add them. That's m plus n. And what do we do with power raised to a power? That's where we multiply the powers. What's going on here? If you have the two things added times the same two things subtracted, you want to learn this because we're going to be using this very soon going in the other direction. You get the square of the first thing minus the square of the second thing. When you have a power of x divided by a power of x, you either get a non-fraction where you're subtracting the top exponent minus the bottom, and this is the way it changes if this number is bigger than this number, if this exponent is bigger than this exponent. Or if this is the bigger exponent, you're going to have a fraction 1 over the bottom exponent minus the top exponent. Okay? So now here's a reminder of what we did yesterday. Factor by grouping here. You got 4 terms, and I realize those could be collected, but we're not going to do that. We're instead going to group these two together and these two together, and for a common factor for the first pair we have x. We could have x times x plus 5, and these two have a common factor of minus 7. I'm going to say minus 7 times x, and we want this to come out to minus 35, so we need a plus 5 there, since the negative 7 times 5 will make the minus 35. And now I can go over here and rewrite this, the common factor out in front, the x plus 5 out in front, and the other part, x minus 7. There you go, there's that. Okay? So, now we're going to learn to factor things like this, where you have 1x squared plus something times x, or maybe minus something times x, plus or minus something at the end. As it says there, there's generic. B and C could be any numbers, but we're going to say 1x squared for today. We'll deal with 2x squared, 3x squared, and so forth tomorrow. So what we need, first of all, are a pair of integers. Remember what those are. 1, 2, 3, negative 1, 2, 3, 0, those kind of numbers. No decimals, no fractions. Whose product equals c, which means the numbers have to multiply out to c, the number at the end, and they have to have a sum. They have to add up to the number in the middle. So, as an example, for this, we want numbers that multiply out to 36 and add up to 13. There's a lot of different ways to factor 36, but 9 and 4 are useful here. 9 times 4 is 36, and 9 plus 4, their sum is 13. And then we would take this expression and rewrite it, replacing the 13x with those two special numbers we just found, the 9x and the 4x, 9 and 4 that we found. And then do factoring by grouping like we did yesterday. Let's see how that turns out. Oh, we need two numbers that multiply out to 12, and the possibilities are 1 and 12, 2 and 6, 3 and 4, and I'm out of ideas, but that's okay because 3 and 4 add up to 7. So we're going to use 3 and 4 to rip apart the middle here. We're going to write x squared, and then instead of writing 7x, I'm going to write plus 3x plus 4x plus 12. And as I wrote this, I could have put the 4x followed by the 3x. It does not make a difference. You can use either order. You'll get the same answer when we're all done. Now we've got 4 terms, and the factoring by grouping should work. Factor out the x times x plus 3. Factor out the 4 4 times x plus 3, and notice what happened. We got the same common factor there. Since we chose these numbers, the 3 and the 4, carefully by making sure they multiplied out to that and added up to that, that's why the factoring by grouping worked. If I would have done 1x and 6x, grouping wouldn't work. If I would have done 2 and 5, it wouldn't work. So, in case you were wondering, here's our answer. X plus 3 times x plus 4 is exactly equal to what we began with. And why we want to do this, there's a lot of reasons. There's a lot of reasons that factoring is very useful. When you take Math 1075, there are 28 lectures in Math 1075. In 15 of them, we use factoring. So that's more than half the lectures in 1075. We'll use some kind of factoring. Okay? What multiplies out to 10? 1 times 10, 2 times 5. That's it for integers. And 2 and 5 add up to 7, so we'll use the 2 and the 5. I'll rewrite this. X squared plus 2x plus 5x plus 10. And I'll mention again, I could have put the 5x first and then the 2x. It doesn't matter. Try it if you don't believe me. Factor out of x, x times x plus 2. Factor out of 5, 5 times, see what's happening? These are matching. And now we're ready to write x plus 2 times x plus 5. If you would multiply this out, you would get x squared plus 5x plus 2x plus 10. See, there's the 7x in the middle. Okay? Now, if you can go from here to here without all this in between because of stuff you've learned in the past, that's fine. I'm doing it this way to make the other questions easier in another day or two when there's not 1x squared but like 5x squared and so on. Doing these today this way is going to make our future work go down more easily. Trust me. How can we multiply and get 8? 1 times 8, 2 times 4. That's it. 2 and 4 add up to 6. We write x squared plus 4x plus 2x plus 8. See, there's the replacement for the 6x. And now here I can write x times x plus 4 plus 2 times x plus 4. And the common factor is right in our face there. X plus 4, x plus 2. Okay? Now, let's do this one. 8, we can do 1 times 8. And I can stop right there because 1 plus 8 adds up to 9. I don't have to make a total list every time. I'm going to write, let me write 1x plus 8x plus 8. See, there's the 9x split up into 2 piles instead of 1 pile. Common factor is x. I can write x times x plus 1. See, that would make x squared plus 1x, or x squared plus x. And common factor there is 8. 8 times x plus 1, that would make 8x plus 8. Here we go, x plus 1, x plus 8. Oh, and another, by the way, if I put the x plus 8 in front and then the x plus 1, it's the same answer because it's multiplication and you can change the order of multiplication as we've been saying for many, many weeks now. Now, if we try to make a list of all the ways you can multiply and get 8. You got 1 times 8 and 2 times 4, and that's it. And neither one of these add up to 7, do they? So this is not going to factor, and this is what we call a prime polynomial. It is not factorable. and it's very useful, like in making codes and in doing encryption, in ATM machines, in credit card numbers, all sorts of things where people have to make sort of secret stuff. Prime polynomials are terribly useful. Okay, how do I know it's prime? I made a complete exhaustive list of all the ways I could multiply and get 8, and none of them add up to 7. Okay, you could sit there for hours and hours trying to get numbers to put there and there so it would come out to this. You can't do it. You can't do it. Okay, not with integers anyhow. Okay, on to the next one, 24. Now 24, that's got a lot of possibilities. There's 1 times 24, 2 times 12, 3 times 8. Why don't we stop right there? You know, I could have 4 times 6 and maybe a few more, but 3 and 8 add up to 11, so I'm going to stop right there. And I'm going to write x squared plus 3x plus 8x plus 24. And now I'm grouping, group of 2, common factor x times x plus 3, common factor plus 8 times x plus 3, and answer x plus 3, x plus 8. End of page 1.